Good afternoon, everyone.
Good afternoon, sir.
I believe you've been enjoying your lecture since we started yesterday on the University Learning Management platform. This afternoon, I will be continuing with the lecture you had yesterday on Physics 129, General Physics Practical 2. And I will quickly take you through an overview of what we did yesterday. And thereafter, I'm going to introduce you to simulation in physics practicals. I also want to believe that you can see the PowerPoint screen. If you can see it, you can just give me a thumb up from the message chat. And I want you to pay very rapt attention even as I go on in this class. God bless you. Let's quickly move on. Now, I believe you're familiar with the figure I have on the screen here. The figure by the left is actually showing a typical linear graph as you have always encountered in the course of Physics 119 practicals in first semester. The general linear equation is given as y is equal to mx plus c. And I also want to believe you are familiar with what each of the nomenclature in this equation stands for. But as a quick review, for those of you who might still not be familiar with what each of this is all about, I'm going to take my time and I will explain as much as possible for better understanding for all of you. Now, when we talk about linear graph, we are talking about a straight line graph. And a straight line graph, as you can see on this screen, is what we have here as a straight line. Linear graph, straight line graph, they are all talking about the same thing. And the equation that explains or expresses what a linear graph is generally given as y is equal to mx plus c, as you can see it here also on the screen. Now, general equation is given as y is equal to mx plus c, where your m stands for the slope of that graph. The slope of your graph is simply talking about how slopey your graph is. What is the gradient of your graph? And is usually given mathematically as change in your y-axis over change in your x-axis. Quickly on the graph, this is your y-axis as you have always seen, and this is your x-axis as you are also familiar with. Okay, now C is talking about your intercept on y-axis. Please take note of that. The intercept C is talking about the intercept on y-axis. Meanwhile, if this graph is projected further down, you will all agree with me. There will come a time when this graph will have an intercept on this x-axis, and that can be computed differently. But of interest now, we're looking at your intercept on y-axis, which is given as what? Which is given as C. Then going further, we look at another graph whereby you plot and your graph passes through what is called the origin. Passes through the origin. The origin of every graph is taken to be the point where x and y are equal to 0. X is equal to 0, y is equal to 0. And at that point in time, where you have x equal to 0 and y is equal to 0, if your graph passes through that place, the implication is that your C is equal to 0. Then your linear equation reduces to what? Reduces to y is equal to mx, because C has been reduced to 0. Okay, going forward, I quickly show you examples of linear equations. Examples of linear equations. A typical example of a linear equation is when you have y is equal to 2x plus 5. It's a linear equation. By the time you plot this value on a graph, you will have a graph similar to what we have in the previous slide. If you have your y is equal to 3x plus 1, that is also a linear graph. If you plot it, you will get a similar graph like what we have in 1. Going forward, if you have a graph, an equation like 5x is equal to 12 plus 3y, it is also a linear equation. It's just that it's not expressed in a standard form like we saw earlier. If you make 3y or y the subject of the formula, this equation can actually give you y is equal to 5x minus 12 all divided by 3. And then that also gives you a linear equation. The same thing with what you have in the fourth equation here. If you have what you have here on this equation, y divided by 4 is equal to 1.5 minus 0.5x. This is also a linear equation. You can actually make y the subject of the formula in this equation, and that makes it to be in conformance with the general linear equation we have shown in the previous slide. So I quickly want to give you an overview of a graph to illustrate certain important features you need to know about linear graph equation. So let's quickly move on to the next slide. Now, the graph I have here is actually the graph of y is equal to 2x plus 5. Y is equal to 2x plus 5. Y is equal to 2x plus 5. And what we have here, if you look at this graph as it's plotted here, y is equal to 2x plus 5, and it's also displayed here. Let me quickly mention that this graph was actually generated using one of the simulation application we have in a repository for your learning. And so this graph, you have what we call y is equal to 2x plus 5. That is linear graph you have here now. Now we can actually go ahead and then draw what we call the slope triangle for this graph, the slope triangle. Now, if I have the opportunity, I want to calculate the slope of this graph, because as you have seen in this equation now, we know the slope of this graph is equal to what? It's equal to 2. If you look at this equation, you subject it to the general linear equation we have earlier, which y is equal to mx plus 5. Y is equal to ms plus c. So by implication, from this equation, we know what our m is, which is the slope, 2. We also know that our intercept is what? 5. Is that okay? Are we together? Now,
yes, sir.
Going on, look at the slope triangle I've just drawn around this equation, around this linear graph. So from this linear graph, I want to go ahead and compute my slope. And whatever slope I'm computing should be similar to what I have in this place. If it's not similar to what I have in this place, it simply means something is not correct. It doesn't have to be the exact value, but there must be comparison. If you compute your own and you get something like 1.99 or 2.01, yes, that is still within the experimentally acceptable limit of error. Okay, so going forward, we look at the slope triangle as drawn here. And we can also see, if you look at this straight line, when it is coming, where does it crosses our y-axis? You can see, obviously, it crosses our y-axis at where? At 5. Hence, we have this 5 as our intercept on y-axis. For this particular linear graph, there is also an intercept on x-axis, which occurs at somewhere around what? Minus 2.5. But like I said earlier, my emphasis is not on intercept on x-axis for now. So I'm just going to concentrate more on what we have before us, which is intercept on y-axis. Is that okay? So let me quickly move on to the next slide. Now, Okay. Going further, in order to still compute our slope, we pick these 2 points on our linear graph, on our straight line graph. This is the first point where we draw our slope triangle. This is the second point where we draw our slope triangle. Are you following me, everybody? I want to believe so.
Yes, sir.
Good.
Yes, sir.
Okay, so with this, we can actually compute or know the value of this point on this graph, this point where I am. We want to know what is the value of this point. Remember, every point on a graph has an x value as well as a y value. I repeat, every point on a graph has both x and y value. How do you determine that? You will determine the x value by tracing that point to x-axis, which is this point. Tracing this point down to x-axis will give me the x value. Hence, which is what? Which is 1. This is 1, this is 2, this is 3. And so I have my x2 here to be equal to 1 because I consider this point as my point 2 on this graph, while I consider this point as my point 1 on this graph. So I have my x2 to be equal to 1. Then I want to trace this same point, this same point 2. I want to trace it to y-axis. Then I trace it this way. Then where does it occur on my y-axis? I have it at 7. So hence I have my x2 comma y2 is equal to 1 comma 7. That is x2 is equal to 1, y2 is equal to 7. Is that okay? Come back to this point.
Yes, sir.
Point 1. Come back to point 1. On the point 1, I want to quickly go ahead and also compute what is the value of x and y on this point 1. My x1, my y1 on this point 1. And then to do that one also, we need to trace this point to x-axis first. Is that okay? If we are tracing this one to x-axis, we are already on x-axis. So we simply pick the value of this point, which is what? This is 0. This is minus 1. This is minus 2. And this will be what? Minus 2.5. Okay, so I have my x1 to be equal to minus 2.5. And that is what you have here. Okay, what about my y? I trace my y to what? Y-axis. This is my y-axis. So this is the point in question. Then I trace this point to my y. Where does it occur? Can I hear you? It occurs at 0. Thank you. 0. And so I have my x1 comma y1 to be equal to what? Minus 2.5 comma 0. Okay. So that is what we have to do here. Then let's quickly go ahead and then compute. Let's quickly go ahead and compute the slope. Okay? So from here now, we set slope is equal to what? Change in y over change in x, which is equal to y2 minus y1 divided by x2 minus x1. And is equal to, what is our y2 that we computed earlier? 7 minus y1, 0 divided by x2, which is equal to what? 1 minus, what is our x1? Minus 2.5. So if you do the, okay, great. So you have 7 divided by what? 1, because you have minus, that reduces to what? 1 plus 2.5, and that gives you 3.5. And if you have 7 divided by 3.5, what do you get? You have 2. Is that okay by everybody?
Yes, sir.
That's okay by everybody. Good. Okay?
Sir.
You
Yes,
can
sir.
then go ahead and compare what you have here now with what you have in the equation. You can see the slope from the equation is the same as the slope we have from the graph. Are we together?
Yes, sir.
Why you also
Yes.
check the intercept? Intercept on this graph is the same thing as the intercept we have on the equation. Is that okay?
Yes.
Good. Let me quickly give time for question before we go to the next discussion for today. If you have any question, you can quickly signify while I recognize you on what I've done so far.
Sir.
Yes, go ahead.
How 3.5?
Speak louder, please, if you're speaking to me.
Please, how did you get this 3.5?
How did I get the 3.5? Okay.
Yes.
Let me quickly go back to the slide and I will explain that very quickly.
Okay, sir.
Now, if you look at what we have on the screen here, we have x2 minus x1, x2 minus x1.
Yes.
From this place, we have our x2 to be equal to 1, which is the one we have here. Then this minus is this minus I have here. Is that okay?
Yes. Yes.
Then what is my x1? My x1 is minus 2.5,
Okay.
which is what I have in the bracket here.
Okay.
Minus 2.5. If you have minus minus, it's like minus times minus. That will give you plus.
Yes.
Minus times minus will give you plus. So what you simply have is 1 plus 2.5, and that gives us 3.5. Then if you have
Okay.
7 divided by 3.5, you will have the answer to be equal to 2.
Okay. Thank you, sir.
Great. Any other question from anybody? Any other question from anybody?
No, sir.
Okay. Only very few of you are responding. Can all of you unmute your microphone and talk to me if you have any question before I go to the next discussion for the day?
No, sir, we don't.
No, sir, there's no question.
Okay, great. Then let's quickly move on to what we have to do next. Now, I want to give you an overview of simulation in physics. In your physics manual, if you check the last 2 chapters in that your manual is actually dedicated to simulation of experiments. Now, let me quickly explain what simulation of experiment is all about. Unlike normal experiment you carry out in the lab, whereby you make use of physical apparatus, you connect wire for electricity, or maybe you make use of spring when you are working with Hooke's law and related experiments, or you make use of a pendulum bulb when you are doing trying to do an experiment that has to do with uh, computing or calculating the period of oscillation of a pendulum bulb, and so on like that. You do those experiments physically in the laboratory using physical apparatus. Science has actually gone ahead. Technology is actually advancing. And the computer is being used to enhance learning in every aspect of human endeavor. It's not limited to online lecture like we are having on our learning management system right away. Computer simulation has also been deployed into science, into several other activity of human endeavor. And so in physics, we want to do some experiments by simulation. And I can assure you, you will get as much knowledge as you can get from the simulation, the same way you will get the knowledge if you are doing the experiment in the laboratory. In fact, oftentimes, simulation experiment offers you much more advantage. And the reason is this: there is no institution that can boast of having all apparatus needed per time. I can assure you. Because science is dynamic, it's not static. Science is changing on daily basis. And so even if you have all the equipment, say last year, by the time you come to a new year, there must have been some changes, there must have been some things that would necessitate development of new equipment and apparatus. And your institution might not have that. Hence, we need to embrace simulation to enhance learning, to improve on our knowledge acquisition, and to be able to get the best from whatever we are doing as students and their teachers. And so for us in the physics, we make use of simulation platform or simulation applications provided by University of Colorado, United States of America. And their website is what you have been displayed on your screen. I will quickly take you through that website, and I will do a hands-on demonstration on some of the facilities available on that university website. And by next week, by God's grace, we will be using one of the simulation for real-time online experiments in this course. So I want to encourage you that since this website is available to you, the one we will work with today, at your own leisure time, take your time to go over it and see what you can do with it. It will really help you and it will advance your learning. So very quickly, I want to share my screen with you. And as I'm sharing my screen with you, I will also go ahead and go to the University of Colorado website, whereby I will show you how you can access this application. Are we together?
Yes, sir.
Can you see my screen?
Yes,
sir.
Okay. Can you see my browser?
Yes, sir. Yes, sir.
Good. So I'm typing the website I mentioned earlier just now. That's phet.colorado.edu. Like I said earlier, this website is powered by the University of Colorado in USA. And so I click that to open that website. Okay. This is the home page of the University of Colorado website. There are over 658 million simulations on this website. You have simulation peculiar to physics, peculiar to chemistry, peculiar to mathematics, peculiar to earth science, peculiar to biology. And so for us, we are interested in physics. So I go to physics, and that displays all the simulations that are relevant and related to physics simulation for me. If you see this left menu here, you can see different sections of or different category of physics topics. You have motion, you have sound and wave, work, energy, and power. You have heat and thermal. You have quantum phenomena. You have light and radiation. And lastly, you have electricity, magnet, and circuits. So you can actually click the category of interest, and then it will take you to that specific page. Alternatively, you can actually look through all this simulation and pick one of interest. Now, I am interested in using this one that is called curve fitting. I'm interested in using the one that is called curve fitting. I'm interested in using the one that is called curve fitting. Please, that person whose microphone is making noise, please mute the microphone. Please, can you all mute your microphone? Hello? Can you please mute your microphone so that we can have a seamless communication? God bless you. Okay? Now, we are interested in using curve fitting, and I will quickly open this. Once you click any simulation of interest, the simulation home page is open. You can actually click the simulation play button here to display it directly. Alternatively, you can download it to your system so that you can use it offline. So in my own case, I want to download it to my system so that with or without internet, I will be able to use the simulation application. Let me also quickly mention, it has finished downloading, that in FED's Colorado repository, we have several types of simulation applications. Some are in HTML5 format, while some are Flash, and some other ones are Java. So depending on the one you download, you will need to meet up with the requirement for you to be able to run it on your system. For instance, if you download a Flash player application from this site, you must definitely have your Flash updated on your system. If you download the Java type, your Java must be up to date and running. And so I simply click what I've downloaded, and it will open and load in my default browser. So this is what I have in curve fitting. Okay, now as a student, you can actually make use of this to plot a graph, and it will automatically compute your slope for you. I repeat, you can make use of this curve fitting to plot a graph. Remember I said we will be working offline, we will be working real-time online. So we'll be working off-site, real-time online. And so for you to plot your graph, for instance, if you have done an experiment using any of the simulation, you can actually come here to plot the graph using this curve fitting application. And I will quickly show you how to go about it. Is that okay? So let us assume an arbitrary number. Let us assume an arbitrary number. I will quickly go back for us to generate an arbitrary number. Let's quickly go back, generate arbitrary number. I want to stop sharing. Okay, let me use another application to generate arbitrary number. Is that okay by you, everybody? So I quickly launch my Excel. I believe you are following my system.
Yes, sir.
Okay.
Yes, sir.
And I'm going to pick one of the equation we had earlier. So the equation we had earlier is what? Y is equal to, can you tell me the equation? Y is equal to 2x plus 5. Is that okay by everybody?
Yeah.
Is that okay by
Yes, sir.
everybody? Okay.
Yes.
Yes, sir.
This is my y-axis and this is my x-axis. Is that okay? Or let me start with x. Is that okay?
Yes, sir.
So I will start that my x is equal to, let me start from 0. Let me start from 1. 1, 2. I will also drag it to 5. Are you following me? Are you following everyone?
Yes, sir.
Let me make it a bit bigger. So I have 1 to 5 as value for my x. Is that okay? Then I want to do auto compute. I will simply enter formula here. I want to do auto compute. I will input this formula for y. And that will be equal to what? Two multiplied by x. My x is located on cell A5. Are you following me, everyone?
Yes, sir.
Plus 5.
I don't understand, though.
Yes, you may not understand this one fully until you learn Excel very well. Then just take note of what I'm trying to do. This is the formula I want to use to implement or calculate the value for my y. I don't want to do it using calculator because Excel has calculator built into it. Are you following me?
Yes,
Let
sir.
me quickly. Let's show you something. Each of the cell you have in Microsoft Excel has a unique identity. I repeat, each of the cell you have in a Microsoft Excel has a unique identity. And the identity is simply the column and the row value of that particular cell. For instance, this is my column D. If you trace column D down and I select this, excuse me. Okay, if you trace this down, this is my column D what? D4. It will also be displayed up here. Are you following me, everybody?
Yes, sir.
This is column D4.
4.
Are we together, everybody?
Yes,
Yes,
sir.
sir.
Yes,
Can
sir.
someone tell me what cell is this?
F7.
F7.
That is
F7.
F7. Great. Now, in this place, what do I want to compute? I actually want to compute something like this. Normally, I want to compute 2 multiplied by
1.
1, isn't it?
Yes, sir.
Plus 5. Is that okay, everybody?
Yes, sir.
Yes, sir.
That's what I want to do normally.
Okay, I don't understand.
Rather than for me to put that value of 1 there, I simply put the cell. Is that okay?
Yes, sir.
That number 1, which is X, is actually located where? Located in the cell A5. So I will replace this with A5. And if you see after typing A5, it's selecting this for me. Is that okay? So
Yes,
once
sir.
the formula is entered and you press enter, the value is automatically supplied for you. Is that okay? Is that okay, everybody?
Yes, sir.
Then I can click
Yes, sir.
and drag down for the last one. I don't have to do it one after the other. Is that okay, everybody?
Yes, sir.
Then very
Yes, sir.
quickly, I need to change this value because let me show you something why I need to modify the value of my X and Y. Now, the maximum value I have on this graph is 10. Are you with me, everybody?
Yes, sir.
For us to be able to do this well, I need to change this from 0.5, then this one become 1, 1.5.
2.
So once I do that and I drag it down, please, someone is distracting this class. Can you please pay attention? Or if you are not interested, you can disconnect. Is that okay? God
Okay,
bless
sir.
you. Okay, so this is what I have here now. So I have my X. I have my X is equal to 0.5. Then Y is equal to what? 6. And so on and so forth. Is that okay, everybody?
Yes, sir.
So
Yes, sir.
I want to implement this
Yes, sir.
value on this graph. So what I have here, I want to plot it on this graph. Okay? So these are the coins you will pick to plot your graph. Pick the first one. I have 0.5 on x-axis. This is my 0.5. 0.5 on x-axis, right?
Yes, sir.
And I take it towards 6. The value is also being displayed.
Display.
It's breaking.
Okay? So you drop
Yes,
that. Pick the next one. You have 1.
1 to 7.
1 is what? 1 on x-axis. Then y is equal to what? 7.
7 on
1 and 7.
1.
Okay? You continue 1.5. You pick. 1.5 is 8. 1.5 is somewhere here. And that will be at 8. 1.5, 7. 8. Is that okay? Then I pick 2. 2 is what? 9. Okay? And finally, 10 is 2.5. Okay? So I have that. Now, take a look at what I have. Automatically, my slope is given here as what? My slope is already supplied as 1.94. And my intercept is given as what? 5.1. Which, when you compare with the original equation, you can see resemblance. Is that okay? So you can see resemblance here. Instead of 2, we have 1.94. And instead of 5, we have 5.1. This is within acceptable experimental limits. Is that okay? 0.06 and then plus 0.1 error difference in each in both slope and intercept respectively. Please, those of you who have background noise, can you please help us? Those of you with background noise, can you please help us? Remember, this is being recorded. Please switch off your mic. And for those of you who are trying to distract this class, remember, this is a video conference and it is being recorded. So be mindful of how you conduct yourself. Conduct yourself as expected of a responsible student of Edo University. God bless you.
Yes,
Okay?
sir.
So, like I said, if you see what we have here now, we have the slope being supplied to be what? 1.94. And you have the intercept on y-axis being given as what? 5.1.
5.1.
So, on a good day, if you are asked to carry out an experiment by simulation and you are expected to submit your report online, you can actually do your experiment, report your data, and then answer questions on your LMS platform as a form of quiz without anybody's intervention. So all you have to do is just to follow the procedure and the direction on what you are asked to do. So I think I want to also give opportunity for questions. And if there are no questions, I will quickly round up at this point in time, and we'll discuss the next line of action of the next class, what to expect, and then what is expected of you. Okay, so if you have questions, you can quickly
Excuse me, sir. How did you get
indicate.
1.94? Is that 1.94? Your M.
Okay, good. I didn't calculate it manually. Is that okay? And I didn't calculate it. Remember, the software we are using is D-Forte. Is that okay? So what I simply did was to place in the values of my graph there. And then the computer automatically compute it and gave me the best equation that fits the values I've supplied. Is that okay?
Sir. Okay,
So it is that
Yes, sir.
application that gave me the best equation that fits the value that I've supplied. Is that okay? Remember,
Yes,
we
sir.
were coming from an equation. We had an equation, y is equal to 2x plus 5. That was the equation. We started from the equation. Is that okay? And from the
Yes,
equation, we went ahead to generate data.
Yes, sir.
After generating the data, then we took our data point by point, took it to the simulation platform to know what equation with this application give us that is best suitable for this graph, for this point we have generated. And then it was able to give us something close to what we had originally when we started. Is that okay?
Yes, sir.
Yes, sir.
Good. So I didn't calculate it manually. If you want to go ahead on your own You can follow the direction I gave you earlier. Draw a triangle on that graph and try to compute it and see what you will get for your slope and your intercept too. You may not necessarily get exactly 2 and 5, but definitely you should get something close to that. Is that okay?
Yes.
Is that everyone? Good.
Excuse me, sir.
So yes, go ahead, please.
My question is it we'll be able to plot a parabola or hyperbola curve on this simulation, or just linear?
This curve fitting, right? Well,
Yes,
let
sir.
me
Yes,
quickly
sir.
say this, that for this course, we are more interested in linear equation. And then your curriculum for this course does not go outside linear equation. However, that curve fitting can plot both quadratic equation and then even a cubic equation can be plotted. And that I will quickly share my screen and also show you right here.
Okay, sir.
But hello, sir.
Just a
Hello,
minute,
sir.
let me quickly attend to this question. Yes, just a minute. Hold on just a minute. Let me quickly attend to this question. Okay, see my screen. If I need, let me use this place. Okay, let me pick this. If you need a quadratic equation, you can actually pick arbitrary points, and then you can have. Is that what you mean, young man? Good.
No.
Then you
Yes,
can
sir.
as well have a cubic equation. You can see the equation being displayed there. Is that okay? So you can actually
Yes,
have both
sir.
quadratic and cubic equation. But like I said, we are only interested in linear equation. Is that okay? But if you want to experiment
Yes, sir.
and explore more, is that okay? You can actually
Yes, sir.
go ahead and do that. And if you look at this place, these are the deviation from the original that is being supplied for you here. Is that okay? Yes,
Yes,
let
sir.
the next person
Yes,
ask
sir.
the question.
But I'm so
Yes,
sorry
next
for
person.
I'm so sorry for
Go
asking.
ahead, please.
When you teaching, when you were showing this graph, after the first graph that I asked the first question from, when you brought up this graph, I was not hearing you very clearly. Like I was not getting everything you were saying. I was so confused.
Which of the graph, please? You need to be specific now.
What told us present
Was it
linear
from my
equation?
PowerPoint? Was it
Like
from the
the way
PowerPoint
you
presentation?
explained it.
So I think she's talking about the simulation.
The
Yes,
simulation, right?
yes,
Okay,
sir.
okay.
Yes, that's
Let
it.
me go over again. Any other question as far as that?
Not really.
Okay, let me quickly share my screen one more time. Okay. Do you have my screen?
Yes, sir.
Good. Let me reset it back to default. Once I launch this application, after downloading it from fet.colorado.edu, what I do next, or what I did next, was to try to generate a set of data for us to experiment with this curve fitting application. And I went ahead to launch a Microsoft Excel application. Now, in the Microsoft Excel application, I recalled the linear equation I'd used to illustrate earlier.
Okay.
And I picked this equation, which is equal to y is equal to 2x plus 5. And from this equation, we generated arbitrary values of x. Are you following me? We generated arbitrary values of x. We started with 0.5, then 1, 1.5, 2, 2.5. These are arbitrary values of x. Is that okay? Then, ordinarily, if you are working with your calculator, what you will simply do is to put the value of x in this equation, which will be what? 2 multiplied by 0.5 plus 6.
5, yeah.
2 multiplied by 0.5 will give you 1, plus 5 will give you 6. However, instead of doing it manually, I simply enter the formula in Microsoft Excel.
Okay.
And the formula is what I'm trying to show you here. Some of you are distracting this lecture, please.
I don't know. Just keep quiet, please.
Can you mute your microphone if you are not contributing to this lecture, please? Okay? Now, you have this formula, which is equal to 2 multiplied by A5 plus 5. A5 is simply making reference to what? To this cell. The cell number 5 in column A. Cell number 5 in column A. Is that okay? And once that formula is there and you click outside, it automatically computes. The next one, look at the formula. It has shifted to what? To A6. Is that okay? Referring to this. And so on and so forth up to the last one. If you generate more data here, let's say I have 0 here, for instance, and I drag this down, the formula will also automatically apply. Is that okay? And that continues on and on like that. So, having done this, then I went ahead to open this and pick from these coins to locate each point on the graph corresponding to these values we have computed. X is equal to 0.5. For x is equal to 0.5, y is equal to what? 6. And that is what I did here, 0.5, 6, x, y. The next one, for x is equal to 1, y is equal to 7, which is what? 1, 7. That's the next one. And so on and so forth. I have 1.5, 8, 2.0, 9, and 2.5, 10. I can go ahead and add this last one to it. This one I just added now, which is 0, 5. Are you following me?
I don't agree.
So I take another point, and I come to this place, and I add 0, 5. Is that okay? I can also compute negative value. Nothing stops me. I can minus 0. Let me say minus 0.2. Minus 0. Let me say minus 2. Is that okay? So I have minus 2. Minus 2. This is minus 2, right? No, this is minus 2. And minus 2, of course, at 1. So I pick this. Minus 2.
Minus 5.
Minus 2 will give me positive 1. Okay? And you can see the more value, the more accurate the equation is becoming. Is that okay? You can also have minus 5.
Yes, sir.
Minus 5 will give you minus 5. Can you hear me?
Yes, sir.
Minus 5 is giving me minus 5. Speak out, I'm not hearing you.
Yes, sir, we can hear you.
Okay.
We can hear you, but it's somehow cracking.
That should be network from your hand. Okay? Okay? So with more values added or with more points added, you can see we have an extremely accurate equation, which is similar to what we have originally. Is that okay? And so that is what you can do with this. If you are giving any experiment to do with this. Is that okay, everybody?
Yes, sir.
Good.
Yes, sir.
Any other question before we call it a day?
No, sir.
Okay, if there are no questions, like I said, I will encourage you. I will encourage you that you make sure you practice this, because when next will be coming up, you will have to do it by yourself and then submit your report online. Is that okay?
That's good.
So God bless you and do have a lovely day.
Thank
And don't forget to keep
Thank you,
safe,
sir.
The name of the site, please.
especially this time. God bless you.
Bye.
You can also meditate on what I have on the screen here.
It's not showing.
Choices are the hinges upon
Bye, sir.
which destiny are built.